This is lesson 85 of Saxon Algebra 1, 3rd edition, and this lesson is on stem and leaf plots and histograms. And this is a statistics-based lesson, and it talks about ways to show on visually, like charts and graphs, when you have lots of information, lots of data to record, and you want to look at it and pick things out, see patterns and such. So a stem and leaf plot is a quick way to organize large amounts of data. And so on this particular stem and leaf plot, you've got your stems, because you look here and the numbers range anywhere from 63 is the lowest to 100 is the highest. So most of these are two-digit numbers. So you take the first digit and put on this side, the stem side, and then you take the second digit and list those out. So you've got 63, 65, 67, 68, and then 71. So 7 being the stem and 1 being the leaf. That means 71. That's how that works. Okay, so taking, for instance, these numbers. You've got 1, 2, 3, 4, 5, 6, 7, 8 numbers, and you're going to classify those. The lowest ones are 1 and a 10 and a 1, and the highest one here is in the 30s. So we've got 12, then we've got a 14 and an 18, then we have a 23, another 23, and a 25, then a 32 and a 35. So that accounts for all 8 of our numbers, and you might ask, well, why in the world do we need to do that? Well, let's take a look at an example. Okay, here's a stem and leaf plot for the scores on a science test. And we see that the highest score was a 97. The lowest score was a 56. And apparently there were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. There were 25 children that took the test. And so here is those 25 test scores broken down a little bit easier. So it's easy this way for us to see that the majority of the scores were in the 80s range. And the next highest would have been in the 90s. Only one person down here in the 50s area. All right, now here we have a stem and leaf plot where the numbers are a little bit bigger. We have 3-digit numbers. So we're going to put on our stem, we're going to put the first 2 digits instead of the first digit. So here we've got 149, 149, 149, and it goes all the way from 149 at its lowest to 200 at its greatest. All right, so here's an example that I found on the internet. This side here is going to be called the frequency, and so here apparently we're talking about a girl's weight, Jessica, and her weight, and her weight was fluctuating between 132 and maybe, or 130 and maybe 150. And so if these were, say, number of days, then, or just say number of times, her weight was in the 140 to 141 range, or 139 to 141 range. That was the highest, and then next to that would have been 137 to 139. So it looks like she pretty much, for the most part, stays in this area right here. One time briefly got up to 150. And briefly, twice, she was at 130. Okay. All right, here we have another one. You can see how it's easy to just look at this graph and see the trends, the patterns, that the highest incidence was between 250 and 300 here of whatever this graph or table was depicting. All right, here's another example with test scores and students. So here the frequency, we are going to put the number of students, and then here are the score ranges. So we've got 0 to 20, 20 to 40, 40 to 60, 60 to 80, and 80 to 100. And you can see that most children scored in the 60 to 80 range on this final exam. We can see that only maybe 4, because this would be 5 right here, students scored between 0 and 20. And then it looks like right at 10 scored in this area, and then 20 scored in the 40 to 60. But the great majority, 40 of the children, scored between 60 and 80, and then probably about 25 maybe children scored between 80 and 100. All right, so these bar graphs that we've called them in the past are now called histograms, and they take the same information that you had on the stem and leaf plot and they make a more of a chart or a graph out of it. All right, your practice problem says Cindy carefully counted the protozoa in 20 slides, and here are the numbers on the slides that she counted. So we're going to make a stem and leaf plot of the number of protozoa counted. All right, so I'm going to take a break from recording here, and I'm going to plot this out, and then we'll come back and talk about it. In the meantime, I want you to go ahead and work it out, and so that you can see then if you're doing it correctly. Okay, so here I've made my stem and leaf plot. And I've got, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I've got 19 numbers. And, oh, well, I missed one. I've got 20 numbers, and they're all represented here. You can see that I put 2 numbers on the stem, and then the single third number in each one, the ones place number on my leaf. Alright, so I can look at this and I can say, okay, my smallest number is 111, my largest is 151. So B over here says, find the range of the numbers. Well, the range then would be 151 minus 111, which is 40. Alright, and then it says find the median, which is the middle number of the data. And so if we have 20, the middle number would be, let's see, 1, 2, 3, 4, 5, 6, 7, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so it looks like the median is going to be right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so the median, the middle is going to be right here between 6 and 9, and if we want to find the midway point between 6 and 9, well, it would be 7.5. So it would be 137.5. All right, then we find the mode. Which number is repeated most? Well, 150 is repeated twice. 142 is repeated twice. 149 is repeated twice. I don't think that I have any numbers that are repeated 3 times. So for mode, it would be 142, 149, and 150. All right, and then the mean, is the average. So we're going to add all of these up. I want you to go ahead and do it on your calculator. I'll take a minute and do it, and then we'll come back together here. Okay, so once you've added them all together, you get 2,734. You divide by 20, which is the number of numbers you have, and your average is 136.7. So if you can see, it's right here in the median range. Okay? All right, now this says using the stem and leaf plot, create a frequency table of the data, and then using that frequency table, determine how many slides contain between 120 and 149 inclusive. All right, so I'm going to go ahead and do this. I want you to do it and then come back and check and see if you've gotten it right. Okay, so here I have written my histogram frequency table, and this stands for the number of, the left side here stands for the number of slides, and the bottom, across the bottom, is how many protozoa on each slide. So we can see that between the 110 and 120 range we have 2, and between the 120 and 130 range we've got 4, 5 between 130 and 140, 6 between 140 and 50, and 3 between 150 and 160. So G asks us to determine how many slides contained between 120, so that would be this line right here, and 149 including 149. Alright, so here we have 4, we have 5 here, and we have 6 here. So that would be a total of 15 for G. Alright, H says what percentage of the slides contain strictly fewer than 130? Well, we know that there were 20 slides in all. And out of those, let's see, fewer than 130, there were 1, 2, 3, 4, 5, 6. 6 out of 20 would equal what out of 100? Because 100 is what we use for percentage. That would be 30 out of 100. So 30% of the slides contained strictly fewer than 130 protozoa. Alright, so this has been a long lesson, but hopefully it's not going to be too difficult for you. Again, if you do have questions, just let me know, and we'll do our best to answer them and help you through it. Alright, see you next time for Lesson 86.